This recording is designed for those training to be trainers for using screening data for decision making, which is part of the screening module delivered by the National Center on Response to Intervention. We will review slides 90 through 163. Consider following along on your PowerPoint slides and notes, although I will deviate from the slides a bit to provide a little more explanation. Decision making is an essential part of an RTI model. As we saw earlier in the diagram of the RTI framework, database decision making is part of the screening process. And data from screening process are used for a variety of educational decisions, not just for student level decisions. It is recommended that database decision making occur at all levels of implementation, including the class, grade, school, district, and state. The following key terms and main points should be focused on during this segment of the presentation. For key terms, we're going to be talking about cut scores, benchmarks, and targets. These terms are often confused, and it's recommended that the trainer look at these and understand these prior to the presentation. We're also going to look at the differences between norm referenced and criterion referenced and how screening data can be interpreted. We'll look at how box and whisker plots can be useful in helping interpret screening data, and how we can use a target identification rate to determine which students who are identified as at risk will receive additional instruction or assessment. There are a couple of main points that you want to point out to your participants. For one, screening data can help answer key questions about the effectiveness of curriculum instruction and inform allocation of resources. Screening measures are not perfect, and so it's important to be aware of a screener's strengths and weaknesses as they are selected and the data is used. If possible, cut scores should be established at the district and not the school level, so that there is consistency and comparability across schools within the districts. Teams should establish routines and procedures for conducting data reviews, establish data decision-making processes, and establish explicit decision rules for assessing student progress. And we'll talk about how to do that. Screening data analysis is important for identifying students who need additional assessment, but it's also important for evaluating the efficacy of the core curriculum and instruction at the class, grade, and school and district level, as well as useful for allocating resources and evaluating the effectiveness of instructional programs for targeted groups. We want our participants to be purposeful in their data analysis, so that they need to determine what they're looking for prior to data collection and data analysis. And it's important to remind them that their outcomes will determine what data is used and how that data is interpreted. District educational decisions for screening vary. We can use screening data for program improvement and curriculum decisions. We can use it for innovation and sustainability decisions. The screening data can help us determine the general effectiveness of our RTI implementation, as well as the general effectiveness of our RTI model. It can also help a district ensure equitable services and supports are across schools. We want to ensure that students across schools have access to similar supplemental supports, to access to effective instruction, as well as using identification rates for SLD that are consistent across schools. Districts can also use their screening data to allocate resources and provide professional development to schools. School educational decisions are very similar, but we can also look at general trends from the school and grade and identify issues. So are there holes in our grade level performance? Are we losing certain subgroups of kids at certain times? We can look at the effectiveness of school-wide curriculum and the instructional delivery. We want to ensure that there's consistent performance across grade levels. We also want to identify areas of need and guidance so that we can set measurable school-wide goals, which will then help with grade level educational decisions. When grade level teams look at their data, they're also looking for trends and issues. They're evaluating the effectiveness of their grade level curriculum and instruction, and they're also identifying areas of need and guidance on how to set measurable grade level goals as opposed to school level goals. This last part is what makes it unique from grade level to school level, is that it will allow them to identify students who need additional instruction and assessment. So how do you know who's at risk? This is an opportunity for teams to come together and discuss quickly, 2 to 3 minutes, how they identify who's at risk at our schools or our districts. The purpose of this slide is to introduce the concept of a cut score. A cut score is a score on a screening test that divides students who are considered potentially at risk from those who are considered not at risk. When we talked about our screening tools, we introduced the concept of classification accuracy, and that's how accurately does a tool identify students who are at risk from not at risk. And we use that classification, or we determine that classification accuracy by using a cut score. So identifying students at risk. RTI success depends on accurate identification of students as at risk or not at risk. This is essential for preventing costly identification errors, including under-identification and over-identification. Perfect screening would result in 100% accurate identification of true positives, are those who actually need support, and true negatives, those who do not need support. Cut scores are often set to over-identify students as at risk, and this is because we want to ensure that we're providing the supports to students who actually need them. In this graphic, we introduce 2 ways that risk can be identified. Interestingly, the first is what we would like to have in education, which is categorical, meaning that a score either is or is not considered at risk. It's sort of a black or white decision. We often see this in the medical field. If a cut score says you are diabetic or you're not diabetic, you have high blood pressure, you don't have high blood pressure. In education, we don't really have it that clear cut, and instead we get what's considered to be a bit more continuous. In this, students' performance falls along a bell curve. You have some students who do really well and some kids who don't do well, and their range of scores varies. We know that their performance on the screener does not accurately predict at 100% if they are at risk or not at risk. The cut score, in a sense, is a best guess based on previous data and data analysis. There are other factors that may lead to the inability of our screening test to identify a kid as at risk or not at risk. You've probably worked with kids who did poorly on their state tests, but in class made 100% on everything. Or a kid who failed miserably all through class and on their assignments, but then aced the final exam. So there are factors in education in which we don't have control over that can make it more difficult for our screeners to accurately predict. So the establishment of a logical cut score is essential for accurately identifying students for additional assessment and supports, and evaluating the effectiveness of the support system. The clinical decision-making model kind of helps us put this into perspective. If you look at the left-hand side of the screen, you'll see that it says not at risk or at risk. This is what our screener said. And at the top, you'll see outcome, at risk or not at risk. This is the actual at risk or not at risk. So screening tools in education rarely 100% accurately identify kids who are at risk or not at risk. So ideally, a screener would only indicate if a student was at risk or at risk, like our categorical. But sometimes we get what are called false positives and false negatives. So in this case, our screener identified the student as at risk, and on the outcome, they actually were at risk, which is true positives. And on our screener, we had a group of students who were identified as not at risk, and on the outcome, they actually were not at risk. We want that accuracy of identifying true positives and true negatives to be very high. we know there are going to be some errors. So for example, our screening test identifies the kid as at risk, but on the outcome, the kid was not really at risk. So we had a false positive. Or our screener identifies the kid as not at risk, and in fact, the kid really was at risk. So we had a false negative. This is why we have additional assessment as part of our screening process, such as follow-up progress monitoring, or teacher observation, or other formal tests. Regardless of the type of cut score, so how you divide those kids who are at risk and not at risk, if you change the cut score, you influence the number of students who are accurately or inaccurately identified. So in example 1, we accurately identified 80% of true positives and 80% of true negatives. And we can see that by the overlapping distribution box in the upper left-hand corner. Now, if you look at the actual bell curve graphics, just to give an explanation, that pink piece is the students who were actually at risk. So 100% of the kids who were actually at risk fall under that bell curve. And 100% of the kids who are actually not at risk or good readers fall under the blue. It doesn't mean 50% are good and 50% are bad. It just indicates that 100% of the good readers are in the pink and 100% of the bad readers are in the blue. The cut score is then placed so that we can best identify, the best fit, identify those students at risk or not at risk. And here you'll see that 80% of the students who were actually at risk fall below the cut score. Thus, we identified 80% of those students accurately. Now, there are a portion of the pink that ended up on the other side of the cut score, about 20%. Those are the students where we got false negatives. They were at risk, but our cut score did not identify them. The same thing goes for good readers. Out of 100% of the good readers, we were able to accurately predict 80% of them. And we had false positives on about 20%. Now, in example 2, we decided to lower the cut score to see what would happen. By lowering the cut score, we increased the accuracy in identifying students who were not at risk. So our cut score allowed us to accurately predict 95% of the students who were actually not at risk, and we only over-identified about 5%. However, we also decreased our accuracy in identifying students who were actually at risk. So you can see by the graphic that by lowering the cut score, we were only able to accurately identify 65% of students who were actually at risk. In other words, 35% of our at-risk population was under-identified and most likely did not receive additional supports that they needed. So where do we set the cut score? So typically cut scores are set so that they produce the most accurate representation of who is at risk and who is not at risk, as shown by the center line. So in this example, we are likely to identify students at risk as accurately as we are identifying students not at risk. And we know that by using follow-up progress monitoring and probably supplemental screening measures, we'll be able to increase the accuracy rate. And you can click on the animation, and the cut score can be adjusted to meet the needs and priorities of districts. So they may say, well, we want to increase our accuracy of correctly identifying students who are not at risk, and accept the possibility of missing a larger group of students who are at risk. So we have limited resources, we might select to lower that. Well, we have to understand in lowering the cut score, although we increase the accuracy of not providing interventions to kids who don't need it, we're missing kids who actually need it. We can take the other route, if you click on the animation, and show that, well, by increasing the cut score, we increase our accuracy in identifying kids who are at risk, but we also increase our over-identification risk. So regardless of the cut score that you use, it's critical that those who are interpreting the data understand how that cut score was developed. There is an optional think, pair, share here. This is a lot of information for folks to give them a time to sort of sit and synthesize and think about what they've just heard. You might also want to ask for discussion or some questions from your audience. Understanding over-identification and under-identification and the effects of those can make us make better decisions about how we use our cut scores. If you think about public health, you may go in for a cancer screening, and some cancer screenings aren't very effective or aren't very accurate, and they tend to over-identify individuals. So say a mammogram or whatnot. Now, in over-identifying someone as having cancer, we also have to go through additional testing to confirm or disconfirm was that cancer screening correct. So we have some additional expense. We also create unnecessary worry among folks. Imagine hearing that you might have cancer, but we can't get you in for testing for another 3 weeks. So you sit and wonder because the test is designed to over-identify, or it just isn't that accurate. We also have the issue of under-identification. So we have a cancer screening that's not very accurate, and it tends to under-identify. In this case, we may miss serious health problems that in the future, because it's too late, we won't be able to address them. The same exact thing happens in education. If we over-identify students at a greater rate, we have the expense of additional testing. We also have the expense of additional intervening services. And in a time when we have limited budgets, we want to be careful about over-identifying students. So we can use cheaper assessments such as progress monitoring to confirm or disconfirm if we're worried about over-identification. If we under-identify students, we miss the opportunity to intervene. And those of you who've worked with older struggling students know how difficult it is to intervene once students become so far behind their peers. So establishing cut scores, you want to think about what is a logical practice, and it must be educationally relevant. Some screening tools, as we saw in our NCRTI tools chart, provide cut scores for you. Those are probably the easiest to use in the beginning. You can also use local norms as cut scores. Some data systems offer users the tools to conduct their own analysis to establish their local cut scores. Some things to think about is that you do need adequate sample size, at least a year of data, in order to statistically calculate how your screening tool predicts to your outcome measure. You can also use cut scores based on the likelihood of demonstrating mastery on your specific core test. Remember, more published measures are probably on broader tests, but if you have a specific core test, you can calculate the predictability of your cut scores to that. And I recommend to calculate those is contact your State Department, someone in your district or school who has statistical analysis experience, or partner with a university who has that level of expertise. Cut scores, although considered arbitrary, are typically based on statistical analysis. So it's not that someone just wakes up and says, I like 63 better. On slide 102, you'll find that there's a short clip of 2 principals discussing how they establish cut scores. This is a good time to allow your participants to hear from practitioners about how they went about this process. It discusses one using a published cut scores and one who has used their own local cut scores. So as I mentioned in the introduction, we're going to talk about the benefits of using district versus school-based cut scores. So there are lots of benefits. And the first one is that we get more effective and more efficient allocation of resources from the district. They're able to target schools with the greatest need. They're able to identify effective approaches for scale up in other sites. They can make decisions about resources that are based on data. And they can make decisions about resource allocation that are timely and relevant, because screening data allows us to be more proactive versus reactive. We also get increased buy-in and use of data by schools and teachers. districts are able to say, well, this is why we're making this change. And schools understand why the data is being collected and how the data is being used to benefit them and their students. You also get a common message and focus activities. So the expectations across the sites are clear and consistent. Each school understands what the outcome that they're trying to achieve. And we also get TA and PD, or technical assistance and professional development activities, that are based on data, based on this common message. We don't have a variety of activities that are occurring just to occur. And I think most importantly is we get increased equity and access to supplemental supports, so that you can ensure that students in School A, School B, and School C are likely to receive the same quality of support. So look at these three schools. These schools were asked to identify the percentage of students who are at or above their cut score. So the district really wanted to know what was the population of at-risk and not at-risk students. And so what you end up with is School 1, 50%, School 2, 63%, and School 3, 48%. Now when you look at this, which schools appear to have the greatest need? Well, most of you would probably say, well, School 1 and School 3. I mean, gosh, almost 50% of their kids are below the target because only 50% of their kids are above the target. However, numbers alone can be deceiving. If districts were to allocate resources based on these school-based cut scores, students in School 1 and School 3 would receive an equal amount of resources. The question is, are we comparing apples to apples? Here is a different way to look at the same data. So this is the actual performance displayed using box and whisker plots, which we'll talk a little bit more about. In this graphic, we know that School 1 significantly outperforms School 3. I mean, its box is a lot higher than School 3's. So while School 1 only has about 50% of their students at or above their cut score, it has set its cut score differently than School 2 and School 3. So it had higher expectations, so it set a higher cut score. Because each school established its own cut scores, it's difficult for a district to determine the actual number of students who are at risk and then be able to make comparisons across schools. Now, if a district was to set their cut scores, what you would see is something a little bit different. So with this district established cut score, it becomes clear that School 3 has a much lower percentage of students at or above the cut score. In fact, only 4%. Remember, it was 48%. Then either School 1, which had about 44%, and School 2 about 20%. So School 3, with this model, would likely receive more intensive supports from the district because it demonstrates the greatest educational need. Even School 2, which had the highest percentage when it set its own cut score, has only 20% at or above the district established cut score. So a standard cut score, or a target as it's called in this graph, across the district provides a more accurate picture of performance and provides more accurate data for allocating district resources and targeting district supports. So here's a team activity to allow your participants to come together and really think about, how does our district determine which students are at risk? Let them sort of think about this, and then if they have a clear definition, how can you ensure that it's known across all sites? And if they don't have a definition, this is a good opportunity for them to think about next steps. Now, we're not trying to get them to establish cut scores or come to consensus about cut scores. This is just an opportunity to reflect on what they've just heard about the use of setting district cut scores versus allowing schools to do their own. So establishing routines and procedures for data decision making is critical. Teams should establish routines and procedures for conducting the actual data review, how they make decisions, so the actual processes they use to make decisions, and explicit decision rules for how we assess student progress. So for example, how do we determine if a kid is benefiting from what we're doing and not benefiting. So with conducting data reviews, we obviously want to conduct data reviews at logical predetermined intervals. Now a logical interval would be just after our screening assessment, and predetermined means, well, we've scheduled it prior to the beginning of instruction. Now if you think about trying to schedule something when everyone's busy in the middle of the year, it becomes really difficult. So if school administrators or district administrators set the expectation that data will be reviewed, say 1 week after a screening, then it's more likely to get done. You want to be sure to use established meeting structures. Some folks use PLCs, others may have a format in which we come in, review the last meeting notes, continue the meeting, and then establish with next steps. You also want to involve relevant team members. This is those members who have authority over their programs. You want to be sure that the team that actually reviews the data can make decisions about the data. So from this video, your participants can learn from several principles about the importance of involving general education teachers in this data review process. If it only becomes a separate process in which other folks make the decisions, you're not going to get the same buy-in from your general education teachers. This video is about 4 minutes and 51 seconds. So database decision-making routines and procedures should be established in writing to the extent possible. This is because we want to ensure that the process that we're using is implemented with fidelity. And unless we have it clearly written out, it's difficult to tell how it's being implemented and if it's being implemented correctly. Ongoing evaluation of selected routines and procedures is also necessary to ensure that they are culturally and linguistically responsive and are leading to the desired outcome. When you're establishing routines and procedures, consider clarifying in writing these 3 questions. First, what are you looking for? Data fishing can be fun, meaning we're just looking through and hoping to find stuff, but it can also lead to problems. It can cause sites to delay the use of data because we don't really know what we're looking for. It can change the focus of the analysis, and it can also help us or make us miss important trends or issues. Identify what you're interested in prior to your data analysis. If you're unclear as to what you're looking for, conduct an analysis of more critical outcomes first, such as reading, math, graduation, and then focus on outcomes in other areas. It is very important to prioritize as we have limited time in order to analyze the data and make decisions about the data. You also want to identify what you're looking for at all levels of analysis. So what the school is looking at should also align with the grade levels looking at, should also align with what each class is looking at. So the next question, how will you look for it? You want to be sure to develop a plan for how you will systematically analyze your data. As we'll see in a moment, data systems provide a lot of data, and we want to be able to identify which graphs we're going to look at first so that we can increase the efficiency of our data analysis. We want to only focus on critical data at first and then delve in deeper if necessary. Now the last question is, how will you know if you found it? You have to make decisions about, okay, we're comfortable or we're not comfortable. Otherwise, you'll continue to look for data to prove one way or the other. So determine how much evidence is needed for a team to identify success or lack of success. And once the team can identify that, they can move on through the problem-solving process in order to develop a plan of action. You also want to consider putting in writing what happens when certain things are found in your data. So for example, if you find that more than 80% of your kids are above the cut score, what should happen? Do we focus more on interventions? Do we increase our number to 90%? What happens when less than 80% have reached the cut score? Do we focus primarily on core instruction? Do we put in a school-wide intervention? And then what happens when we see a general lack of progress? Or we see different progress rates among different target groups. So it ensures by having those decision rules that something will occur when we find it, not that we'll just admire the problem when we find it. So data collection is not nearly as difficult as the data analysis. So screening data can assist teams in answering many questions that they're asking. However, data analysis can become overwhelming. Clicking on this animation, you will see a variety of graphics that pop up. And those graphics represent the various types of data that can be pulled from a lot of published data systems. So it can be very overwhelming. Many data systems provide users more output than they know what to do with, and teams struggle from where to start, what data is the most important, what data is there to help them answer their questions. And data systems are great for helping manage the data. However, if we're unfamiliar with the data system that we're using and what it has to offer, we can become paralyzed by its output and maybe only use one or two because that's how we know how to use it. In this section, we're going to discuss different types of data that can be pulled from screening, and it's not specific to a certain data system. If you're training a group that is using, say, Ames Web or Dibbles or some other published data system, we recommend pulling some of the graphs and replacing these non-standard graphs with something that comes from their data system. It will help them see more relevancy and then understand a little bit more about what they're looking at. So data analysis, as I mentioned earlier, should occur at the district, the school, the grade, and the student level. And this is important because the student may be struggling because of something that's occurring at the district level. Or this grade level may be struggling with what's happening because of something that's occurring at the school level. So when data analysis occurs at the district, they're looking at the big picture from the district. What can they do to help there? And then you see the same thing at the school, the grade, and the class, and then eventually we can focus on the student. If we focus on the student first, we're sometimes going to spin our wheels and not be able to help kids because it's not a kid issue. So what is the purpose of your screening data analysis? Well, obviously we want to identify those students who need additional assessment and instruction. We want to evaluate the efficacy of our core curriculum and instruction. We want to know how to best allocate our resources. And we want to evaluate the efficacy of instructional programs for target groups. Now, although that makes sense, it may not be consistent within your district or your school. So we're going to have an opportunity for your team to come to consensus about why are you screening? Because if the district isn't clear about why screening should take place, it's definitely not going to be clear to schools or teachers. And then you get less buy-in, and then you're more likely to get inaccurate data because people don't take it seriously, they don't know what's happening. So as a team, you're going to use handout 1, the purpose of screening, to identify why you're screening. Trainers, I recommend getting folks to identify at least 3 because it will help with the rest of this section about how we can use graphs to answer some of those questions. These are some of the more common but sometimes confused terms that you'll see while analyzing and interpreting data. You may have seen the terms used interchangeably, especially by publishers of screening tools. For purposes of this presentation, we refer to these terms as follows. A cut score, which we've heard before, is a score on a screening test that divides students who are considered potentially at risk from those who are considered not at risk, often associated with the classification accuracy that we saw on our screening tools. We also have what's called a target or benchmark, and this is a predetermined level of performance on a screening test that is considered representative of proficiency or mastery of a certain set of skills. So remember, cut score separates risk from at risk, where target or benchmark is separating those who've mastered and not mastered. Criterion scores are scores on a screening test that separate students into performance levels. So we've seen this often with Dibbles or something where it says these kids are deficient, emerging, or established. Now the target or benchmark is more often than not used as the same score as the cut score, especially when the cut score is predictive of the state test. However, it doesn't have to be. For example, schools or districts may choose to set higher benchmarks or targets that are predictive of higher standards, while setting cut scores to be more predictive of who's actually at risk or not at risk. This is why it's essential for teams to understand how the cut scores, targets, and benchmarks were established. The term cut score is sometimes used to refer to criterion scores that separate students by performance levels. That's the triangle we often see. It is important to remember that the purposes of these terms, cut score and criterion score, can be very different, and we're going to talk about that a little bit. Before we begin analyzing some sample data, it's important to make sure everyone understands how screening data can be presented and interpreted. Although we'll be using some fictitious data, the procedures that we'll be using apply to most types of screening data. Now remember, facilitators, you can input the type of tool or data output that the participants use, and this can be very useful and increase the relevancy. So screening data can be interpreted in several ways. What you're interested in, so for example, are you interested in comparing students or determining the number of students at risk, will determine how you will interpret your data. Norm referenced, criterion referenced, or just using target scores. So for norm referenced, students are often measured against others, not a defined criterion. What it allows is a fixed proportion of students to pass or fail, regardless of what the score is. So when you use this, you will always have kids, regardless of how low your class is, who fall in the upper average and those who fall in the low average. It is a very effective way of comparing students. It's based on a bell curve. So in the middle we find the midpoint or the median, which is really your 50th percentile. Half of the population is on one side and the other half is on the other. In a normal distribution, the majority of people fall in the middle, so you'll see that's where the biggest part of it is. The farther from the edges, or the farther from the middle and you get out to the edges, you tend to see that there are less people. So on the right-hand side, we have very high achievers, like us, most teachers. And then on the left-hand side, we have those who are lower achievers. In a typical classroom, we would expect similar distribution of skills among students. Some with very high, some with very low, but the majority with general skills. Box plots are a common way to graphically represent norm reference data. So think about the bell curve turned on its side. What you end up with is a box plot. So the box plot are somewhat similar in shape and representation. So in a bell curve, the middle line is the median score. So it says the 50th percentile, meaning that half is above that line and half is below. The lines on the top represent the 75th percentile and the 25th percentile. And what you end up getting is a green box, and that's what we consider average. Now if you think about what's average, the kid at the 75th and the kid at the 25th are probably going to look very different, which is why we encourage the use of differentiated instruction. But in general, their scores, although they're varied, fall in what we consider to be an average range. Now there are kids who fall well below the 25th and well above the 75th, and that's where we get into less students, so we use a line to represent that. And then any kid who falls up beyond the 90th and the 10th tend to be outliers. So this is an example of a student who's being compared to his peers. So the dot, the blue dot, is the student, and the box plot represents the peer group that this kid is being compared to. So how is this kid performing? Well, we would say he's well below his peers, because the end of the orange line represents the 10th percentile. So this student is well below the 10th percentile. You can also look at norm-referenced box and whisker graphs to look at groups, not just students. So this type of data analysis would be helpful in identifying kids who need additional support. Now, facilitators, when you're presenting this type of data, it's not necessary to go into interpreting the data. What we're trying to show here is that screening data allows us to be able to see differences in performances. So if I look at grade level 1, I can see the green, which is the comparison group, is pretty different than our grade 1. Or the same with green and the grade 3, the average group, is pretty different than our grade 3 school. So we can use this data to identify where are the differences, which then allows us to delve in deeper and identify what the actual cause may be. So criterion reference is a different way of looking at it. With criterion reference, students are measured against a defined criteria. So it doesn't matter who is taking the test and whatnot, there is criteria that says a kid is proficient or not proficient when we use this. Criterion reference tests are often but not always used to establish competency. So if you took a driver's test or if you took your end of chapter test, we want to know, do you know the information or do you not? Unlike a norm reference, the criteria typically don't vary year to year because it's irrelevant of the population that's taking the assessment. There are multiple ways to determine the criterion, and one of the examples is to use percentile ranks. So those of you who are using some data systems may say, well, how do I know? Well, I can take the average group over time and say the score at which is the 10th percentile is deficient. I can also determine that the score between the 10th and the 25th percentile for the average population is probably emerging, and we know by the time they get to the 25th percentile they may be established. Now this is just an example, and we recommend that you look to your publisher and the information they provide on how you would set the criteria for your particular tool. This type of data representation, so here we have the green, which is established, and the yellow, which is emerging, and the red, which is deficient, is how we often think about RTI. It's that triangle. And if you click on this slide, what you'll see is the animation that shows you how we get that visual representation of our triangle. So what does it mean? I mean, why would I use norm reference versus criterion reference? Well, the first table shows how students can be grouped if we use norm reference data. In this output, students are compared with their grade level peers. Some students fall up in the upper performance range in comparisons of the peers, while others fall in the lower range. This type of data output allows grade level teachers to see which students have the lowest and highest scores in the class, and what is the average performance group of this class. So it can help with differentiation and grouping. Now if you click on this slide, what you get is the same set of students but presented with criteria. So we get a little bit different data. In this output, you can see that all students are performing below the criteria. These data can assist in evaluating the efficacy of the core. So same group of students, norm reference, they're comparing against their peers. You're always going to have high kids and you're always going to have low kids. But if we have an established criteria, a cut score or a target that says this is where kids can be, then we can determine how effective is our system. And in this case, we would say our system is probably not very effective. Data decision making can also be used by looking at benchmarks or target scores, not just the criterion reference scores, so we're not dividing them into groups. In this case, you either are or you aren't. These scores are typically based on statistical analysis and can be correlated with high-stakes testing. So for example, students who reach the benchmark have an 80% likelihood of scoring proficient on the state test. Using target scores can assist with determining overall effectiveness of the core curriculum and instruction, while the criterion reference scores are probably a little more helpful in determining groupings for instructional programs. So here's an example of looking at the criterion referenced and the target together. So the target score, remember, is typically a score where we feel confident that a student has mastered or is proficient on the assessed skill. In other words, these students will probably not likely need any additional assistance. In this example, several students who met the established criteria for emerging fall below the cut score. And that's because we probably look at those kids as bubble kids. So those kids who are in the red, we would, by our criteria, we'd say, okay, they're definitely deficient, they'll need some additional support. Those kids who are in the yellow probably need some additional support, but maybe not as intense. And those kids in the green, although they're okay now, we're not very confident about their skill level, so we may want to do additional supplemental support, say at the primary level, to ensure that they meet the target, which would increase our confidence about their performance levels. Now that we have some understanding about screening data and how we can look at data, we're actually going to look at how we can make some district decisions, so some district data analysis. If your participants are primarily district folks, this would be a good opportunity to ask them what type of questions are they interested in answering at the district level. What type of data do they use? Just sort of engage that prior background knowledge about analyzing data. If you're working with participants who are not at the district level, you may just want to present this from the approach of, this is the types of things your district can look at when you're using district level screening. So here's another look at the district level decisions that can be made using screening data. And we're going to look at some of this district level data and see how we can use screening to assist in the instructional decision-making process. And remember, we're looking at program improvement, curriculum decisions, innovation and sustainability, so the general effectiveness of what we're doing. We're going to be able to look at equitable services across schools and how we can support schools. And then we can also look at allocation of resources and professional development. So districts could use data presented in this manner to compare schools at different grade levels and answer questions about effectiveness. For example, is the primary prevention working for most students in the schools? Districts can also use this type of data to make decisions about resource allocation. And looking closer at the schools in this district, the district might find that school E, which is the one in purple, seems to perform lower than the other schools for grade 1. The district may consider analyzing the causes of this difference. They may ask themselves, what is school D doing that causes them to perform better than expected, while what happens at school E that causes them to perform lower than expected? Another thing to consider is that school C scores above the cut scores for both grade 1 and grade 3, but below the cut scores for grade 2. There's a lot of variation in performance, and this graph provides us a snapshot. It doesn't tell us what's happening, it just tells us that something's happening. The district may be interested in why there appears to be such variation across the schools despite having a standardized district curriculum. Districts can also look at school or district-wide performance by grade level over the year. So this chart shows changes in the percentage of students meeting the established criterion scores for each benchmark. This chart indicates that although 55% met the criterion for established, that's the green section over the fall, at the beginning of the year, 80% met it by the end of the year. So what we could say is, well, it appears that instruction in grade 2 is effective. The district may also be concerned, though, why is it the majority of students enter grade 2 not on target or not established for readiness for grade 2? So what happened in first grade? Why is second grade having to catch up? Now remember, we're just looking at snapshots to see if there are general trends and issues. And here we see a general trend is grade 2 is quite effective in catching students up, but a trend is kids coming into grade 2 are probably not as prepared as they need to be in order to benefit from grade 2. Districts can also analyze performance by subgroup. So for example, are Title I students performing similarly to other students, or students with disabilities performing at similar rates as those without disabilities? It appears, for example, on this data that students in the other category who are not in, say, an identified status such as Title I or special ed are doing fairly well. And that's probably our general education group, depending on how our data has been tagged. The district would probably need to obtain more information about why is it that our Title I students are not doing as well, or our special education students are not making the same progress. What we're looking for with the district is general trends. And what we're seeing here is that certain subgroups in our school are not benefiting the same as our general population. Districts may also compare performance across ethnic groups. So this graph shows that some ethnic groups are not performing at appropriate growth rates while others are. So if we look at our general population, and it really depends on what our general population is, we would see for us the Caucasian students and the Asian students are performing similarly. But we have certain subgroups of students, such as our Hispanic and African American students, who are performing well below their peers. So it may be that we need to put in appropriate interventions, evaluate our policies, identify a curriculum that's more appropriate for this population. So here's another way to look at it, is we may be interested in looking at ELL learners versus non-ELL learners. Now the target scores that we see here, we've said, well, we have an established benchmark where we want our students to be. So in this case, what we see is those who are non-ELL learners or English language learners perform above the targets. But those students who are English language learners perform below the target. Now, if you imagine, if you're only looking at your data averaged, it may look fine. But when we start to disaggregate it, we start to see that there are some trends that we may need to pinpoint and address before they become too big. So let's take a look at some school level data analysis. Similarly to the district level data analysis, consider having your audience talk amongst themselves about what types of questions or information they're interested in gathering from their data. If you have primarily school level folks, I would spend a little bit more time in this area to give them some time to build that background knowledge about why we're going to use our data. Here's a look at some school level decisions, and we saw these earlier. So we talked about general trends, the effectiveness of the school curriculum, and areas of need. So think about those at a minimum as we walk through these slides. Remember, this is fictitious data. So schools, just like districts, can analyze performance across grades. In this graph, what you see is a comparison group, which is in green, and the school, which is in gray. We also show the target line, which is where they expect students to be at that grade level. And that's the black line that you see on both the composite and the school. In this graph, we see that grade 2 and grade 3, our school, are below the target and may need additional support. A school with this data would probably identify trends and issues from this general graph, look more deeply through a problem-solving approach and analyze for causes, develop a plan, implement that plan, and then evaluate it over time. Remember, these graphs don't tell us why something the way it is. Instead, it just shows us that something is different. Schools can also look by benchmark period, by grade level, and look at the performance of the average students across each of those grade levels. And what we tend to look for is a general increasing trend or progress over the grades. In this graph, it's pretty simple, and what we see is that grade 1, from fall to winter to spring, they make an enormous amount of growth. But when we get to grade 5, the difference between fall, winter, spring is not that great. Now, some people might say, well, something must be wrong. Well, how much growth is expected really depends on the tool that you've selected. So make sure you understand what is the expected change from benchmark to benchmark for each of the grade levels when analyzing your data. Just like district, you can also analyze the growth by target group. So this will depend on the variables that you have selected within your school. So do you have a lot of detail about individual kids, or do you just have general detail? In this school, African American and Latino students appear to be performing well below the target, and that's a green triangled line. The decline in scores from winter to spring among African American students is also cause for concern, and as a team we would look more deeply about what's happening. We can also look at grade and classroom level analysis. And facilitators, just like the other two sections, you can consider having your teams talk about what is it that we're interested in looking at our data. Here's another look at the grade level decisions that can be addressed with screening data. And we've talked about those trends, the overall effectiveness, and this is where we'll get into identifying individual students who may need additional assistance. So analyzing that core effectiveness, it's a big question for many of us. So grade level teams can analyze the effectiveness of the core by looking at various types of data. This is one example of how the data can be graphically represented. We use the triangle because the triangle tends to be associated with RTI, but you could also have a bar graph or something else. As you can see by this example, we have the percentage of students meeting the established criteria, which is in green, and this grade level in the fall was 45%, and by the time they got to winter increased to 75%. That's a huge difference. So it appears at this time that the curriculum that the students are using in this grade level appear to be effective. There is some concern, though, as we saw in the previous graph, about why the percentage of students who are on target at the beginning of the year is so low. This can be an indication that the previous grade level does not adequately prepare students for this grade level. So in using that same data, we look at the spring. And you can see by the time the students get to the spring, 80% of them are meeting the established criteria. So we would be confident that the curriculum and instruction used in this grade level is effective. And in fact is more effective than we would expect because they've had to make growth beyond what would be typical. I want to mention here that what we would like to see is 80, 80, 80. And a lot of people want to see this 45, 75, 80 because it appears to present a level of growth. Now, in reality, the growth in these sections is done by the changes in the actual benchmark or target that has been established. So as that increases, we want to maintain the same level of students who are on benchmark. So ideally, we'd like 80% on target in the fall, and 80% in the winter and in the spring. So here's a different set of data. So we can look at the core curriculum across the year and say, okay, well, how are kids doing? Well, in the fall, these students seem to be fairly well. We have about 73% of students who've met the benchmark. Now, we probably would just do the same thing that we would typically do in our class and focus on those students who needed additional instruction. Now what happens is when we get our winter data back, we notice that the percentage of students meeting established decreased from 73% to 53%. It appears that during that time, the primary prevention, what we were providing for most students, which was the core instruction and curriculum, was not effective for a large number of kids. So we need to look at what's happening as a whole. And in fact, if we had focused on those kids in secondary and tertiary and ignored the kids in primary, we don't know if there were kids who were in the yellow at the beginning of the year who moved to the green, and then a bunch of kids who moved from the green up. So that's something we would look more in depth about. Now, because we see this and we've analyzed the data quite quickly after getting our winter benchmark, as a team we would probably decide to change what's happening at our class or our grade level. And what we end up getting is that we do see an improvement in overall scores. So the data indicated a change in performance among students from 53% to 76%. Now, as a classroom teacher, this is a lot of effort, because it's not that I would have to provide what would be typical growth. I have to provide typical growth plus additional stuff, which can be very tiring and very time consuming. So it's better to prevent this decline in the winter so that we don't have to make it up in the spring. So growth, just like at the school and district, can be analyzed at the grade and class level. So given the large number of data at the district and school level, some gaps at the grade or class level may be missed, and that's because you may have one or two students who fall into certain categories. So class and grade level data should follow the same data analysis routine to identify potential gaps in performance. Grades in class can also look at growth by target groups, so general education versus special ed, or if you have Title I or some other subgroups. So for example, in this class, the general education students are making progress that's higher than the target group. So that's the blue, general education, and the green is the target group. But students who are in special education remain below the target group or show little progress. So this is where we may target more of our resources. Schools can also do grade level or classroom level comparisons. So this chart shows the average student performance for 4 fictitious classes in a grade. So we can compare performance across the classrooms at different points in the year. For one, we can determine, did we provide the teacher with a homogeneous group of students? Are certain teachers getting the similar types of supports? And what we might find is that there are kids in one class who are struggling more than another. And it's not that it's designed to punish or evaluate teachers. The purpose of this data is to allow us to see where do we need to allocate our supports. So as opposed to taking a paraprofessional, providing it equally across 4 classes, it may be more important to provide a paraprofessional in just 1 or 2 classes. We can also use ranking graphs, so as a way to look at the students within a class or a grade. So this type of analysis can allow us to see how kids fall within the performance of others. We can use this information to differentiate instruction or to create small groups. So for example, we have our kids who are in the deficients and the emerging probably have more similar skills, although not guaranteed. So now that we've identified who's at risk, the question becomes who is going to actually get a support. So when class and grade level analysis is complete, data teams will come together and look at the performance of individual students. So now we're looking at individual students to determine which kids would benefit from additional support. With screening data, we can compare an individual student performance with the norm group. So this is our norm referencing, and a target score, which is the black line in this graph. If you look at the green boxes, you can see that the group appears to be making progress over time, which is what we would like to see. While this student, shown in blue, is making some progress across the year, his progress appears to be insufficient to close the gap with his peers. In fact, if you look closely enough, it appears that the gap may be actually increasing, although very small, over time. We want to intervene as soon as possible to prevent this gap from getting any larger. Analyzing student data are important not just for students who are struggling. We also want to ensure high performers continue to make the appropriate level of progress throughout the year. This may also include a student who needs additional support. It just may be different support than the student who's well below average. So how do we use screening data to determine who will need additional support? After determining the effectiveness of the primary prevention and establishing instructional plans for improving core instruction, teams can begin to analyze data to determine which students need additional support. Identifying students in need of additional support is not always as simple as providing interventions for students who are well below or well above the cut score. It may vary based on needs and resources of the school and on the target and criterion scores chosen. There may be students who fall below the cut score that cannot be served by existing resources. So we need to look at which students to allocate the resources to based on how much resources are available and where is the greatest need. We may need to identify the lowest percentage of students whose needs can be met by existing resources. So for example, maybe we only have enough funds to support 20% of our population. That's how we will then set a target identification rate. If there are many students who fall below the primary cut score, we want to make sure that the focus is on improving core curriculum and perhaps looking at a class-wide, school-wide, grade level-wide intervention before providing individual supports to students. Some practitioners use criterion scores to establish what students fall into which group of instruction. In this example, this school may have said any students who fall in our yellow category or emerging category will receive secondary supports, while those students who fall in our deficient category will automatically receive tertiary supports. Although this method does provide an established process for grouping, it can lead to problems in schools where the majority of kids fall below the two categories. Imagine having 50% of your kids fall in the red or tertiary category. We just don't have enough services or supports in order to make that happen. You also have to remember that the number of kids in this model will change by benchmark and by year. So it's a little more difficult to establish how we're going to do our staffing and how we're going to do interventions if we're unsure about the number of kids that will be served in secondary and tertiary. Some people may choose to say, well, any kid who falls below our cut score, that's who we're going to give supplemental support to. Well, let's look back at the example that we showed earlier. If cut scores and target scores were used to determine supplemental intervention in this district, then in school 3, 96% of their kids would be receiving individualized or small group instruction. Now that's just not really practical, and it's not really realistic in trying to make improvements in overall school services or school system. So the focus for these schools, given the high number of kids who fell below the target, should really be about improving the core curriculum and the core instruction. Another way to identify who or how many students are going to get support is to use what we consider to be a target identification rate. So this is different than a cut score or target, and it doesn't really come with a number or a score on the test that identifies the student. Instead, the target identification rate is the proportion of students who are identified. And it's typically based on the amount of funds that we have and the services that we have available. Unique target identification rates may be specified for different skill areas. So for example, we may serve 30% of kids who are struggling in reading, but only 10% of kids who are struggling in math, because that's how our funding sources are coming. Here's a way to look at it more graphically. So in this example, School 1 has resources to serve about 20% of its students in its secondary and tertiary system. So therefore, it sets its target identification rate as the lowest 20%. In contrast, School 2 only has enough resources to serve 15% of its population in its secondary and tertiary. So its target identification rate is set at 15%. Now, if you remember, we had that ranking of the students from our screening. That would be a way to identify the lowest 20% or the lowest 15%. Regardless of a school's target identification rate, if more than 20% of the student population is identified as at risk by the cut score, the focus should be on improving core curriculum and instruction. The district should help identify resources available and help schools in figuring how to allocate those resources. So there's some things to remember. Good data in, good data out. You have to know where the data came from and the validity of that data. Otherwise, all of the decisions you made could be completely invalid. When we look at data analysis, we want to focus on the big picture first and on all students first. So we want to know, are most students making progress before we start looking at the progress of individual kids? We need to know, is it a systems issue or is it a kid issue? All instructional and curriculum decisions should be based on data. So if somebody asks you, why did you make that decision? You should be able to show the data that says, here, this is why. And you want to keep it simple and efficient. When we start out, we tend to do things a little more cumbersome or not as fluently as we would like to. So keep in mind that you can revise and refine your process. If people say, this is really cumbersome, I would take it to heart and say, you know, it is, and let's see if we can figure out a more efficient way to do it. This section closes with a team activity. And this team activity is really to get people to think about their target identification rates. So what are the current practices they have for identifying students for secondary and tertiary? And are these practices effective, and why or why not? The reason we close with this is because this is usually the primary reason in which people use screening data. We put it last because we also want them to look at their core curriculum effectiveness, be able to analyze by different subgroups to determine first, is it a systems issue versus a kid issue.